Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 4-2 for February-March 2023 Mechanics. Question 1. A crate of mass 200 kilograms is being pulled at constant speed along the horizontal ground by a horizontal rope attached to a winch. The winch is working at a constant rate of 4.5 kilowatts. And there is a constant resistance to the motion of the crate of 600 newtons. Find the time it takes for the crate to move a distance of 15 meters. That is part A. Now, I'm going to have this diagram here. First of all, for constant speed, okay, acceleration is equal to 0. I'm going to show you two ways you can do this. If this is, let's say, the crate, let me just represent it with this. It is being pulled along this horizontal rod, and then it reaches, let's say, somewhere there. So this is 15 meters. From here to there, and then there is a constant driving force. There is a driving force here, and then there is a resistance force to the motion, okay, 600. Now, we know that power, we are given the power, okay? They said that the winch is working at a constant rate of this, that is power. So power is the rate of doing work, okay? It can be FV. I can actually just say power is equal to rate of doing work. Work is force times distance, right? So I will have force times the distance, then divide by the time, okay? So power is 4,500. Remember, it is in kilowatts, so we multiply it by 1,000. And then the force here, since we are having this minus this, when you use F, okay, is equal to MA. Okay, F is equal to MA. You are going to have the driving force here minus the resistance force, then is equal to 0 because acceleration is what? 0. So meaning the driving force is actually going to be equal to the 600 newtons. You see that? So that means for constant speed, the driving force is going to be equal to the resistance force. So here I'll put 600. Then the distance traveled is 15, divide by the time taken, and I want the time. So from here, time is going to be 600 times 15, divide by 4500. 600 times 15, then divide by 4500, that is 2. So the time taken is 2 seconds. But there is also another approach, but that is the simplest. Alternatively, I can say maybe power is equal to FV, because remember, distance over time is speed. So I can say is equal to FV, okay? So the power is 4500, then we shall divide by the speed, okay? Then this one is equal to the driving force. You see that? So if we are having F, which is equal to MA, and the driving force is now 4500 over V, minus the resistance force, which is 600, acceleration is 0. This will mean that when you take this one this side, you'll get the velocity as 4500 divided by 600. So this one goes, then this will be 7.5. Yes, this will be 7.5. Now here you are taking a longer route, but you are getting the velocity here. Then from here, you can say that time is equal to distance over speed. So the distance moved was 15 over now the speed you have gotten, okay? So what is the distance? 15 over the speed, 7.5. it still gives you the 2 seconds, but this appears to be a longer route than this one here. That's why it is even 2 marks. So they expect you to use this one. The rope breaks after the crate has moved 15 meters. Now that means the driving force has to be equal to 0. So this one has gone. It would have been here, but now it goes off. So it is 0. Then this one will move a shorter distance, a very small distance ahead. Okay? It's just free movement. In other words, it will move at a deceleration. So find the time taken after the rope breaks for the crate to come to rest. So I will say this means the driving force is equal to 0. Now, using F, which is equal to MA, now the driving force, remember, we had something here. The driving force then minus, then is equal to the MA. So I will have 0, then minus, the resistance force is 600, then is equal to, the mass is 200, then times A. So meaning acceleration is going to be equal to -3 meters per second. It moves with a deceleration, okay? Because it is coming to rest. Now, after that, we can now use our V is equal to U plus AT. So the final speed is 0 because it is coming to rest. And then the initial is going to be 7.5. Now, this one, if you never used this one, this alternative here, now you have to calculate and find the V, you see, which is 7.5. So me, I just slide it down here, and then we have, that is 7.5, then plus, acceleration is -3, then times the T. So if I bring this one this side, it will become a positive because it's a minus, is equal to 7.5. Then when you divide all through by 3, then T becomes 2.5 seconds. That is that.